Hi, I'm Alan Hawes. Welcome back to Cypress Academy WICED Wi-Fi 101. Let's get back to it. In the previous videos, I took you through 1, what sockets are, 2, a simple application protocol I call WWEP, and 3, how to create, read, and write to sockets using the WICED APIs. Let's put this whole thing together and make an end-to-end application that implements the WICED Wi-Fi Example Protocol. Remember that the WWEP is a simple database protocol. The client can write values into the database in the form of W for write, device number, a 16-bit device number, register, an 8-bit register, and a 16-bit value. For instance, W1234567890 will write the value 7890 into device 1234 register 56. The client can also read by sending R123456, which the server will respond with A1234567890. In other words, the value 7890, which is in register 56 on device 1234. First, let me show you the client. The client is really simple. I will just read the state of a button, then send alternating zeros and ones to a register, which is just the 16-bit checksum of my MAC address on the server. The project starts with WICED_init and WICED_network up. Then I create a thread to process the button presses and send them to the server. In that thread, I start by getting my MAC address by calling WICED Wi-Fi get MAC address. Then I calculate the checksum. Then I use WICED hostname lookup to find the address of the WWEP server. Finally, I wait till the user presses a button using the semaphore. Remember semaphores from the RTOS videos? The last piece of the client is the send data function, which actually does the socket connection. First it calls WICED TCP create socket, then WICED TCP bind, and finally WICED TCP connect. Notice that I'm carefully checking the error codes from each of these API calls. Now that I have a connection, I format the message using sprintf, then I make a stream with WICED TCP stream init. I write and flush the message with WICED TCP stream write and WICED TCP stream flush. And finally, I close everything and move on. Now let me show you the server. It's also pretty simple. The server has a little bit of initialization with WICED init and WICED network up. I use the linked list from the library. Remember chapter 4 when I showed you the library? This allows me to implement a simple database. I also create a thread, which I call non-secure. The reason I call it non-secure is that all of these transactions are taking place on the open internet in plain text. In the next several videos, I will introduce you to encryption into this system. The server thread creates a socket with WICED TCP create socket. It initializes a stream on that socket with WICED TCP stream init. Then I actually attach my socket to the port with WICED TCP listen. Now I need to make an infinite loop that accepts a connection with WICED TCP accept. When I get a connection from a client, I read its IP address that I can display on the screen, I read its data, and I send it to the database with the process client command. I print out the output with my function display result. I send the response with WICED TCP stream write, and don't forget the WICED TCP stream flush. And finally, I clean everything up with WICED TCP stream dinit and WICED TCP stream init. Then I'm ready to go again. You can dig through the database read and write functions by looking at the functions process client command and the output function display result, which are available on the GitHub site for this class. Neither function has anything to do with the TCP sockets. It's just a little C programming, and you can look at it easily. In the next video, I'm going to fix the problem of a lack of security by introducing you to encryption. You can post your comments and questions in our Wi-Fi developer community. Or as always, you're welcome to email me at alan_hawes@cypress.com or tweet me at AskIoTExpert.